Hello everybody. Today we will discuss binomial theorem for CHSC students. Binomial theorem is the most important concepts in algebraic concepts. So the term binomial is being derived two Greek words that is bi and nomial. Bi means two and nomial means terms. An expression having two terms, that is called binomial expression. But the thing is, the binomial theorem is essential for the algebraic concept. In case of binomial theorem, we have one concept that is called binomial. Binomial is the sum of two distinct terms like x plus y or x plus a. Let it be x plus a. So x plus a is the binomial concept. The theorem is the power of x plus a, that is x plus a to the power n. Look at here, a binomial is a polynomial with two terms such as x plus a. Often we need to raise a binomial to a power. In this section we will explore a way to do just that without lengthy multiplication. This binomial concept can be proved by lengthy multiplication. By eradicating lengthy process, we can have x plus a to the power 0 equals to 1. Anything to the power 0 equals to 1. X plus a to the power 1 equals to x plus a. X plus a to the power 2 equals to x square plus 2ax plus a square. Similarly, x plus a whole cube equals to x cube plus 3x square a plus 3a square x plus a cube. In this way, we can have x plus a to the power 4 equals to x to the power 4 plus 4ax cube plus 3a square x square plus 4a cube x plus a fourth. Observe this thing. In particular index, here index is 0, here index is 1, here index is 2, here index is 3, here index is 4. But the result is having, when index is 0, the result is having one term. Index is 1, result is having two terms. When result is index is 2, result is having three terms. Similarly, it is observed that the expression resulting expression contains more than one terms according to the corresponding index. See the pattern. Can you make and guess what is the next one would be? Look at here. Here x square, x cube, x to the power 4. Here second term a square, a cube, a 4. Similarly, x plus a to the power 5 equals to x to the power 5. You have to find the coefficient. But term is a x fourth. Another coefficient x square and x cube. Next coefficient we have to find it out. A cube x square, a fourth x and a 5. Now in each term it is observed that in each term the power is similar to same as the index. The sum of power of two terms here, 4 plus 1 is 5, 3 plus 2 is 5, 3 plus 2 is 5, 4 plus 1 5, here is 5. We can easily see that the pattern on the x and a's, but What about the coefficients? Make guess, and then as we go well, we will see how you can do it. See the Pascal triangle. Here 1, and for 0, when the index is 0, the term is expressional term is 1. When index is 1, so two coefficients 1 1. When expressional index is 2, so coefficients are 1 2 3. In case of index 3, 1 3 3 1. In case of 4, 1 4 6 4 1. In case of 5, 1 5 10 10 5 1. How many terms are there? 1 2 3 4 5 6. For the 6, we can have 7 such coefficients: 1 6 15 20 15 6 and 1. But the thing is, how to find this thing? One is coming from x plus a to the power 0 equals to 1. This is 0 c0 0. What is the value? 0 factorial divided by 0 minus 0 factorial into 0 factorial, that is equals to 1. So the value is 1 over here. In case of x plus a to the power 1, x plus a to the power 1 equals to, one coefficient is 1 c0 and other is 1 c1. 1 c0 value is 1, 1 c1 value is 1. In case of x plus 2, x plus a to the power 2, that is equals to 2 c0, 2 c1 and 2 c2. 2 c0 value is 1, 2 c1 value is 2, 2 c2 is 1. How? We have known that NCR equals to n factorial divided by n minus r factorial into r factorial. N minus r factorial into r factorial. In case of 2c0, here n value is 2, r value is 0. Put it n factor 2 factorial divided by n minus r, that is 2 factorial into r factorial, that is 0 factorial. 0 factorial value is 1, that is 1. That is 1. Similarly, you can find 2c1, that is 2. How? Check it out. 2c1, 2c1, that is equals to 2 factorial divided by n minus r, 2 minus 1 factorial into 1 factorial, that is 2 factorial divided by 1 factorial into 1 factorial, that is 2 by 1, that is 2. Similarly, 2c2 equals to 1. In case of similar way, we can have 3c0, 3c1, 3c2, 3c3. In this way, all these values can be calculated by the combinatory formula. This triangle is the Pascal triangle, and it would give us the coefficients for a binomial expansion of any power if we extended it for enough. This is the rule for which this coefficient for 0th index, first index, second index, third index, fourth index and fifth index. This is the good for lower powers, but could get very large. We will introduce some notations to help us and generalize the coefficients with a formula based on what was observed here. This is called the Pascal triangles and would give us the coefficients for a binomial expansion of any power if we extended it for enough. Then factorial concept or symbol. Exclamation symbol is the factorial symbol. 0 factorial, we have known that 1 factorial value is 1, n factorial equals to n whole into n minus 1 dot 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 multiplication up to 1. Like 4 factorial equals to 4 into 3 into 2 into 1. N must be an integer greater than or equals to 2. What this says is, if you have a positive integer followed by a factorial symbol, you multiply the integer by each integer less than it until you get down to 1. Up to 1 you can multiply it. For example, 6 factorial equals to 6 less 1, 5, 4, 3, 2, 1. All these numbers are to be multiplied. Your calculator can compute factorials by the symbol exclamation, symbol, which is under the mathematical menu or probation. The symbol and the theorem of factorial or theorem of binomial. Factorial value is multiplication, but binomial concept is power of binomial terms. Binomial expansion is a plus b to the power n, that is a to the power n plus n into a to the power n minus 1 to b plus n into n minus 1 into divided by 2 factorial, n into n minus 1 divided by 2 factorial, a to the power n minus 2 into b to the power 2. These things are to be continued, these patterns are to be continued up to b to the power n. But the thing is, this symbol can be replaced by the combination formula. In the a to the power n term, the coefficient is 1. To make it coefficient 1, that is combinatorial formula is nc0. nc0 formula or value of nc0 equals to 1. Similarly, for this concept, nc1 a to the power n minus 1 into b. For this third term, nc2 a to the power n minus 2 into b to the power 2. Fourth one, nc3 a to the power n minus 3 into b to the power 3 dot 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 ncn b to the power n. One observation is there. In combination, n power is remaining constant, but r value is increasing by 1, 0, 1, 2, 3 up to n. In simultaneously, the first term power of the first term decreases by 1. Here is n, here is n minus 2, 1, n minus 1, n minus 2, n minus 3, like this. Here is a to the power 0. But the second term power increases. Here b's power is 0, b's power 1. Second term power increases by 1. 1, b to the power 2, b3, bn. In this way, we can complete our formula. General term. General term can be represented by r plus 1th term in the binomial expansion for a plus b to the power n is called general term. So term is standing for t. R plus 1th term t r plus 1, formula is ncr a to the power n minus r into b to the power r. To find fourth term, that is t4, substitute r equals to 3. 3 plus 1 is 4. Middle term in the expansion a plus b to the power n. If n is even, the middle term is n by 2 plus 1th term. Another concept, if n is odd, then two middle terms are there, n plus 1 by 2th term and n plus 1 by 2 plus 1th term. Middle n plus 1 by 2th term as well as its successor. Here is the expansion x plus a to the power 12. Simple expansion, you can follow this thing. Now, and the fifth term matches the term we obtained. This is the fifth term. Fifth term can be calculated. Here x plus a to the power 12. You can calculate the fifth term by applying T5 12C5 a to the power 12 minus 5 7 into b to the power 5. T5 12th term you can calculate, and the thing is in this expansion, observe the following. The powers of a and x add up to the power of binomial. A's power increase in power of x, decreases in power of from term to term. Power of a increase in the power and x decrease in the power of term. Next, powers on a are 1 less than the term number. Symmetry of coefficients, that is second term and second term to the last. Look at here, second term. Here second term is first term, second term. Here from the last, second term, same. Third term 66, from the last third term 66. In this way all are symmetry.